Yes.
Okay. So good morning, everyone. My name is Monique Dosanjh, and today I'm going to be presenting about forest restoration in Southern Ontario's conservation areas impacted by emerald ash borer, a case study with Credit Valley Conservation. Oh, this is not working. Okay. Oh, perfect. Okay, so I'm going to begin by defining the problem. So forests in Southern Ontario have a significant component of ash and have therefore been significantly impacted by emerald ash borer. So the main impact has really been a change in forest structure and composition due to this loss in overstory ash, as well as the proliferation of invasive plants. So in this capstone, I'm going to be using Credit Valley Conservation, or CVC, as a case study. So CVC is where I completed my summer internship, and so they provided the data that I'm using for this project. So a bit of background about EAB and ash in North America. So EAB is a wood-boring beetle that has had a devastating impact in North America. It's able to kill a large healthy ash tree in about 3 to 4 years. In terms of ash species, they are widely distributed in Canada. So the 3 common tree species for ash are white ash, green ash, and black ash. An important thing to note is that a large proportion of Ontario's forests are secondary growth, which means they have a lot of successional species like ash. Another important thing to note is that urban environments present unique stressors such as development, recreation, and fragmentation, which impact forests. So moving into some of the ecological implications of EAB, we've got the obvious one, which is widespread canopy gaps from the loss of ash. We've also got the loss of black ash in wetlands. So black ash really plays an important role in regulating water quality and quantity. Another impact is the spread of invasive plants. So ultimately, there's this need for restoration to improve species composition, as well as improve ecosystem functioning. So moving into a bit more in depth about the Credit River watershed. So there's about 23% forest cover, and it's made up of about 55 native tree species. However, 65% of the deciduous and mixed upland forests are predominantly comprised of only 3 species. So these are sugar maple, white ash, and American beech. So we've got American beech, which is declining due to beech bark disease, and then we've got white ash, of course, declining due to EAB. So really what we're getting left with are these forests that are dominated by sugar maple and are highly simplified. Another issue in the Credit River watershed is that there are a lot of invasive plants. And then we've also got this ongoing threat of forest pests and diseases. So on this figure, you can see that 51% of the inventoried woodlands are vulnerable to current and future pests, including things like Asian longhorn beetle. So moving into the 3 objectives for my capstone, the first thing I wanted to achieve was to identify potential restoration sites. Secondly, I wanted to determine a set of criteria to spatially prioritize these restoration sites. And lastly, I wanted to identify techniques to then restore these post-EAB impacted areas. So here we can see the Credit River watershed. So it's made up of the Credit River and its tributaries, which flows through 9 municipalities, including Orangeville, Brampton, and Mississauga. So ultimately, the Credit River then flows into Lake Ontario. Now moving into the actual study area for my project. So I used a subset of the 10 core conservation areas that CVC has. So I got access to the ecological land classification data for 490 polygons. So this included vegetation data. And this made up about 920 hectares. So in this map, it's all of the red areas. So now moving into the criteria I use to prioritize my restoration sites, I'm going to start off with the ecological criteria. So we've got first core area, which I defined as anything 100 meters away from the forest edge. Then I've got rare plant species, which are species of conservation concern, or SCC, tier 1 and 2, which are essentially species at risk. And then I've got proximity to streams and wetlands. So for streams, I used a 30-meter buffer, and for wetlands, I used a 100-meter buffer. So I did use a binary scale. So for each of these criterion, it was either a 0 or a 1. Moving into my disturbance criteria, I chose to look at invasive plant species. So the way that I narrowed down this list is I looked at CVC's high priority invasives list, and I picked out the category 1, which are transformers, and category 2, which are highly invasive plant species. And then to further narrow that down, I only picked the invasive plants that CVC actively manages. So these are the 7 that I resulted in. So I've got common buckthorn, garlic mustard, invasive honeysuckle, multiflora rose, lesser periwinkle, goutweed, and phragmites. Moving into how I classified my areas. So these are the 5 categories that I used. I'm going to go into depth on one of them just to show an example of how I did it. So if you look at the low priority for invasive management category, the way that I did it is I looked at the sum of the ecological layers. So the ecological value could have ranged from 0 to 3. So if it got a 1 and there were invasive plants present, so it was greater than 0, then it got a low priority for invasive management. Okay, so the first thing I needed to do was identify those EAB impacted areas. So what I did is I identified all of the areas in the Credit River watershed that contained ash. So of those 490 polygons, 294 contained ash, which results in about 545 hectares. So on the map, you can see it's all of the yellow areas. So an important thing to note is that there's really only 3 conservation areas that had enough coverage. So they are Silver Creek and Terracotta Conservation Area, Limehouse Conservation Area, and finally Rattray Marsh Conservation Area. So now moving into the actual maps that show the restoration prioritization, we're going to start off with Silver Creek and Terracotta Conservation Area. So on this map, you can see that there's a lot of green. So this indicates that it's in the monitor category, which means it has ecological value, but it doesn't have any of those 7 invasive plants. So we can see that the percentage is 45.8%, which is certainly quite significant. Next, if we look at the invasive management area, so that's the yellow, orange, or red, it's about 22%. So 22% of this conservation area is in need of invasive plant management. If we move into Rattray Marsh, we can see it's a different picture. We've got a lot of red and a lot of orange. So there's a lot more invasive management here. So we can see that it's about 64.6% of this conservation area that is in need of invasive plant management. Now, if we move on to some of the other properties, we're going to focus on Limehouse Conservation Area because it has the most coverage. We can see that there's a lot of yellow and a lot of green. So the yellow, again, is low priority for invasive management. So we can see that for the invasive management areas, it's about 45.5%, which is still quite significant, although there is less high and medium priority areas. So here in these bar graphs, we're going to take a look at those 3 conservation areas and only focus on the low, medium, and high priority for invasive management. So on the left, we've got restoration priority on the x-axis, and on the y-axis, we've got percentage. So we can see that those red bars really have the highest percentage. So that is Rattray Marsh. And then on the right, we've got area on the y-axis, again, still restoration priority on the x-axis. And we can see that now it's actually those blue bars, which represent Silver Creek Conservation Area, that have the highest area in those invasive management categories. So essentially what I would say for the result is that Rattray Marsh is the highest priority for restoration, and this is followed by Silver Creek Conservation Area. Okay, so now how to restore these areas. So it's obvious that invasive plant control is going to be required. So the 3 main ways that this is done is chemical control, which usually involves herbicides, mechanical control, which involves things like hand pulling, and biological control, which involves things like bioherbicides. After invasive plants have been removed, it's often necessary to plant native species. So some of the things to consider are site suitability, diversity, and climate change. Okay, so what this project really provides is a flexible approach to spatially prioritize restoration. Of course, it is data dependent. So just to illustrate how it's flexible is if we wanted to focus on accessibility, for instance, we could look at trails and we could overlay a trails shapefile to see where those high priority areas overlap with trails so we can easily get into those areas to restore them. Next, I have this point about climate change increasing disturbance. So I wanted to really highlight this because EAB is really just one such disturbance. We're expected to get even more. So it really is important to focus on the root of the issue. So the root of the issue is really that our forests are in a degraded state. They have a lot of invasive plants and they're not very resilient. So this brings me to my 3rd point, which is we really need to improve the resilience of our forests. And a way that we can do this is by enhancing diversity. So I'm going to talk a bit about the insurance hypothesis. So in the context of forests, this essentially states that if we have increased forest diversity, then it really buffers against the impacts of disturbance. So the rationale is that if we have a forest with a variety of tree species and functional traits, then there's a higher chance that some of those tree species are going to be able to deal with certain disturbances that come their way. So this is going to lead to enhanced ecosystem function. It's also important to think about adaptive forest management, which involves things like monitoring, evaluation, and adjustment, because this can really help us to learn more about forest dynamics and see how forests deal with things like disturbance and environmental change, ultimately leading to better decisions with regards to forest management and restoration. Okay, so moving into my conclusions. So really it is a combination of invasive plant control, native tree species planting, and also broader measures to enhance forest resilience that are required. Improved quantitative inventory and monitoring could certainly help. So a way that it could have helped with this project is if we had data on different plant species and also the abundances, we could have figured out which areas are more diverse and therefore likely to be more resilient to disturbances. This could help us figure out which are less resilient, and then we could focus on restoring those first. So a way that we can achieve this is have stronger partnerships between conservation authorities, universities, municipalities, and governments to really improve this research and monitoring. Okay, so this brings me to the end. I'd like to thank Professor Sandy Smith and Professor Danijela Puric-Mladenovic for supporting me through all aspects of my project. I certainly couldn't have done it without them. I'd also like to thank my external supervisor from Credit Valley Conservation, Alana Svilans, for providing the data and constantly being available to talk through my project and giving me advice. I'd also like to thank these particular people from Credit Valley Conservation. They helped me again obtain data, and they had meetings with me to discuss more about my project. I'd like to thank MyTax for funding my summer internship. I'd like to thank my MFC classmates for helping me with my presentation and giving me feedback. And finally, I'd like to thank my fiance, Monique Dosanjh, for helping me organize my data in Excel. All right, thank you, everyone.
Okay, thank you very much, Monique. We're going to open the floor to Alana, your external supervisor, to offer any questions or suggestions to the school. Hi, Alana.
Hello. Hi there. Shall I ask a question?
Yeah.
Sorry, I couldn't hear what you were saying. I know that as part of your project, you did a number of site visits. Can you speak to like the primary invasive species that you saw in these ash-heavy areas?
Yeah, certainly. So buckthorn and garlic mustard were probably the top two that I saw. There was a bit of multiflora rose as well, but I think buckthorn, especially in the literature, that's something I've noticed, that it seems that after EAB, this is something that's really encroaching in these areas.
Thanks.
Do you have any questions here? Right. Unmute this microphone so you can use it. Test. Okay.
Thanks, Patrick. Thanks, Monique. Great overview. As I was listening and thinking about it as if I was the manager, I was, I'm kind of interested in another layer or two. And can you think of other criteria that you should be sort of layering in here for making decisions as a manager?
Yeah, I think the main one that really I wanted to include was ash dominance. I think certainly the areas that have the most ash are likely to be the most impacted. But of course, this is not really possible with the ELC data. So again, this kind of goes into my discussion where I really think that quantitative inventory could have really helped, because if we know the area, including tree species diversity as a criteria, as a second criteria, would really help, because we can figure out which are likely to be less resilient going forward and then really focus on those.
Yeah, no, I that's, 100%, that makes sense ecologically. I guess I was thinking as a manager, I'm thinking about like Rattray Marsh, where, clearly that's a recommendation to go for that one. But if I was trying to make some decisions and I have a limited budget, I'd think, okay, what's my cost to do Rattray versus some of the other ones? And what's my probability of success? Because why would I invest a lot of money for poor success in Rattray, even though it's the most impacted perhaps,
Yeah.
when I could spread that money where I'm going to more likely be successful. So I'm wondering, could that be incorporated into this kind of analysis above and beyond the ecology of this?
Yeah, so I think my idea was to include that. So I kind of did in my project, just by really those high priority, really the areas that are most impacted, they're high ecological value, but then they are also impacted by invasive plants. That was kind of the idea. I didn't want to give, those, because I think when you look at practicality, you're not always going to just go after those areas that are in the worst shape. Like that's often not the most bang for your buck. So that was kind of the rationale that I had used to really create this.
So it's incorporated.
Yes.
Yeah. Great. Thanks, Monique.
Yep. I think Danijela has a question.
Danijela, okay, here I come.
Great work, Monique. I had a question about those properties along the lines of what Sandy said. They're like a little nuggets on the landscape. What about the surrounding landscape? You can put money and pour money into a site and still you cannot fight invasive species.
Mm-hmm.
So what do you think that some other landscape criteria could be included into something like this?
Yeah, certainly. I think that's a really good point, because really, if we're just restoring this one area that's surrounded by other invasives, then there's really no point. So yeah, I think something that could have been included is just really looking at that outer landscape. I think unfortunately, there's this data not have the plant about, what kinds of invasive seeding in after that area.
Thank you.
Thank you. Monique, you might want to be, I don't know, adjust your microphone a bit. It cut out a little bit in the back, and I don't want folks
Sorry about that.
to miss what you're saying. We have a question here online from Leonardo, and he asks, would you include species at risk as an additional layer?
Yes, so that was my intention with using the rare plant species. So the reason I didn't include species at risk is because the data I received was 1 kilometer by 1 kilometer, so way too big for my purposes. All of the conservation areas, so pretty much I would just have every single conservation had a species at risk, so it would have no purpose. But I think if I had some higher resolution data, like certainly that's an extremely important criteria.
Any follow-up question there, Leonardo?
No, thank you so much. I appreciate it. Thanks.
Yeah, no problem.
Excellent. Jay is on the line, and Jay has a question. Go ahead, Jay.
Hi, Monique. Good job. I have a couple of questions, actually. One is the ash abundance question. I mean, the ALC does have ranking of species abundances. And I wondered if you thought about that, or obviously the ranking used in the ALC seems pretty crude. So I'm wondering if you thought about like looking how well it was working and thinking about that.
Yeah, so my initial idea was to use plant abundances, and really I had worked in Excel, but I realized the way that it is just very, it's not quantitative. Also, it only dominant plant species, so I really didn't find it was wasn't very quantitative. I was like, there's those greater than, like they have double times and not double, like it's very just, I don't know. I guess I don't think it's very easy to interpret.
Cool. Your mic is still kind of breaking up a bit there. I don't know if you can get a bit. My final question here was to do at the end, you talked about resiliency and increasing the functional roles in forest ecosystems. So I was kind of wondering about that. I mean, so is the idea here, we think we understand what we should do, and so we go in and modify forests to quote, fix them up so they're more resilient? I mean, it would seem to me the sort of baseline would be to try to get them back to being as natural as possible. That seems like a more kind of trustworthy goal, if you ask me. I'm just curious about your thoughts on that.
Yeah, certainly. I mean, I think I obviously simplified it a bit and said just diversity is the goal, which certainly it isn't. But I think the important thing here is also, as I mentioned, like we have all these secondary growth forests, so they really contain a much higher proportion of ash than they would have naturally. So I think that was my main goal, was to take these really simplified forests and just increase their diversity. I don't think it's about just planting as many types of species as you can. I don't think that would be a great solution, but especially, you know, now we have like American beech dominating the areas and white ash. That is certainly going to reduce the resilience, I think.
Cool, thank you.
A couple more questions. Anyone have anything you'd like to raise?
Hi, Monique. Great job on your presentation.
Thank
It was
you.
really cool. I actually grew up in Mississauga, and I've actually been to Rattray Marsh and Silver Creek, and so I'm familiar with the areas. Was the social component of, you know, the fact that Rattray Marsh is by the lake, but it's in a very urbanized area. I went to school like literally down the road from Rattray Marsh, and we used to go into the marsh. And then versus Silver Creek, which is kind of surrounded by some more sparse farmland and houses. Was that something that you took into consideration, or sort of not really, just because it does add such a complicated component to what you were looking at?
Yeah, so again, this is one of those things that initially I certainly thought about it. It was an important factor because Rattray Marsh is one of the most heavily used ones, and I think that certainly has an impact. But again, because it's so hard to add this as a criteria and to really include it properly, I tried to stay away from that and just keep it simple. And yeah, that was kind of the goal. But great question though. Thanks.
Thank you. Do we have one final question? I thought I saw one over. Okay, well, then that works well. Thank you very much.
Thank you, everyone.